Hi guys, good morning. Well, today I wake up and still I'm waiting for the job. So sometimes the refrigeration job is on your phone. So someone if he's call you, you will go there. And otherwise, sometimes it's good time for relaxation and to organize your van, clean your van, think about the materials you don't have, just go buy it. So there is different type of the hours basically. All hours is not about the job. Sometimes it's about the preparation. Sometimes about the um, sometime about uh, work and sometime about the advertising yourself, going to shopkeepers, leafleting, getting in touch with the shopkeepers. That. So today I was thinking to talk about the troubleshooting. Troubleshooting, it's a big part of refrigeration, and uh, there is some troubleshooting like is very common, but some of them is very rare. Occasionally is happening, but um, it's good to know all of them, and then you're gonna be uh, very comfortable with the job. Like whatever the problem is, you can tackle it, and with the confidence. But the key thing is for the finding the problem, no matter what is the situation is, it's a day or night, you have to be calm, cool, and collective. Not to get panic or rush for the things, and try to find the problem very quickly, or um, or come quickly to conclusion like what is the problem, and then that can be wrong as well, because you have to study the system, what's wrong with the unit, and then come up with the right solution. So we're gonna start with the problem number one. Let's say you go in the one unit and there is no cooling or reduced cooling. Let's say our set temperature, or shall I say required temperature, is 2 degrees or 0 degrees in that case, but our control will show 10 degrees or 15 degrees. So for that can be a few a few things can affect that one. Number one, that will be low gas. That means the system is leaking from somewhere and there is no gas in the system. So that is easy to find out, obviously by touching even the condenser or the pipes. If you touch the, as we know, there is two pipe. One is going out from the condensing unit to the evaporator, and the other pipe is coming back from evaporator to the condensing unit. So the pipe is coming back. We know that one as a suction pipe because it's sucking the gas basically back to the compressor. So that gas will cool down the compressor, help to cool down the compressor. The pipe is going out of the condenser to evaporator. We know him as a discharge pipe. So if by touching the discharge pipe, if the discharge pipe is not warm, it's supposed to be warm, because once the gas is released from the compressor, it is in sensible heat. So it's supposed to be, you touch it and you feel the heat a little bit. In summer more, but in winter less, a little bit. But it's supposed to be a little bit warm. Or the touching the dryer, and if the gas is circling, then the second thing that can be happen, we looking for possible blockage. Sometimes the gas can be blocked. If the system have a side glass, so you can see through the side glass, and the gas should flowing in the side glass, like is running from compressor to the evaporator. If the gas is stand still, just like a water in the glass, that's not a good sign, that means the gas is not circling. If it was circling, just like a river, you see the water is keep going. But if it's not going and it stands still completely, that is a sign of blockage. That blockage where can be? That blockage can be in filter, and it can be on expansion valve, which is the ORFs is there. Well, expansion valve, as we know, is metering the voice. There is uh, a filter is going in, and they call that one ORFs. So that can be blocked. So in this case, it makes sense to change both of them. Change the ORFs, or expansion valve himself can be faulty, meaning that uh, is he either closed or open. If it's closed, obviously the gas is not going through. But if it's open, it's too much cooling there. So that's another thing. But in this case, if it's closed, the gas is not going through. So how to check the expansion valve? There is a filter inside the expansion valve. By pressing that one, it's supposed to be like spring, push in, and then it's gonna come up little bit. But it feel like it's kicking back. So if the expansion valve is not faulty, then just change the ORFs and the filter. The complete ORFs, you change that one. Whatever number it is, it can be number 1, 2, 3, 4. Put the same number back there. So that is the metering device, because the gas going through that ORFs. That's that. And the other possibility, let's say if our system is ice tap completely. That ice tap, it can be in the two situation. One is the whole evaporator is gonna ice up. That's problem with the defrost, obviously, especially in the freezer, even in the fridge as well. And if there is gap in the cold room and the air is entering, obviously the ice is building quickly. If there is no electric defrost, the ice will build up. So the defrost, it can be different. It can be a reverse cycle defrost, which is the gas is going back from the compressor. Instead of entering the condenser, is going through the evaporator. And that is one type of defrost. And the second type of defrost, and more common one, is the electric defrost. And the third type of defrost, obviously, there is no electric defrost. There is no return gas defrost. It's just they give time, basically. You just put the time there. Every 4 hours, 25 minutes is good for defrost, and that time is allowed for the ice to melt it. So that is that. There is one more thing. Let's say the part of the section of evaporator, which is the expansion valve, is located. Sometimes that section iced up completely for some reason. The ice tap, and I've seen it myself, the ice tap, it will be that much, which is completely cover the expansion valve, and the sensor, which is coming from expansion valve connected to the suction pipe, they're covering that one, and the expansion valve get confused, because the job of sensor is to fail the cooling inside the system, and fail that one and report it to the expansion valve. If he's failing, if he's covered up by gas himself, if it's fail cold, and he will close the expansion valve. If feeling like there is cold, but actually there is not cold. So you make sure all the ice is melted and nothing is covering the expansion valve. So that is that. So we talking about, at the moment, we cover two sections. It's just the low charge or system, which is ice tap completely. Ice must be go away completely, and you can do it with the hot water. The safe way to melt the ice, it will be hot water. Put inside hot water inside the pressure system and spray it on the ice, and it will slowly will melt away. It will take time, but that's the safest way to do it. Okay, and different methods for that. You can use a heater. You can use if you have electric heater, you can turn on permanently for about 30 minutes if it's working, for example. So there's different methods. The meaning is, what the bottom line is, sorry, is to get rid of the ice, because ice in the system is confuse the refrigeration. The other thing is the number 3, which is affecting the system. For example, if the fan is not working, let's say a system is got a dairy cabinet, a cooling system, has got 4 fans and 2 of them is not working. So obviously the air is not circulating, the cooling is not circulating, so that can be as well. And also we have to make sure is the condenser fan is working. Sometimes the condenser fan is not working, and that's going to be complete no cooling, and on top of that the system go very very hot. So that's that. And then we got another thing, which is overcharge. Overcharge is if you see your section pipe is iced up completely. In some cases some part of the condenser is icing up as well. That's not a good thing, because that means the liquid is coming back inside the condenser. The system is overcharged and the liquid is coming back inside the condenser, and that will reduce the life of the compressor. So we make sure we get rid of that one by a phase 404 gas, completely take off the gas and recharge it again, but very carefully not to overcharge it again, the system. So that is that. The number 4, we're talking about the moisture in the system. Let's say if there is moisture in the system and the person charge the gas once you open the pipe and then charge the system, it doesn't vacuum the system properly, or um, is this thing happen again and again, everyone is opening the system but never vacuum the system, so the moisture can be inside the gas, and that will reduce the cooling as well, reduce the cooling. The other things is the other factor, and which is a major factor, before you go in the system and you start checking up like what is going on, um, we have to think about, is this system is good enough for the job? Let's say you have a cold room 2 meter by 2 meter by 2 meter. So immediately, check the condensing unit, check the evaporator capacity. Is that unit is up to the job, or is that means the unit is under power, is not up to the job, or too small, or that is, can be a reason as well. The other reason is um, the condenser dirty. If your condenser is dirty, and you make sure you clean that one regularly, but there is some special liquid, you can put him inside the system and then wash it with the water. So we have to make sure our condenser and fans working, all of them in very good condition. The other problem can be the fan can be very dirty. That means the dust and rubbish sit on top of the fan, and the fan is working but not circulating the air properly. Because the more thicker they get, the slower they circulating the air. So we make sure we take all the blades out of the fan, wash it properly, put it back. If you feel some fan is slow, change the fan as well. So that's that. The other problem with the system, it can be uh, let's say, for example, I've been in the one system, the shopkeeper say, I want to change this unit. I said, why? You change the unit? Everything is working fine. He said, yes, everything is working fine, but I never get the proper cooling, which is I needed. So the proper cooling for him, he was like minimum 18 degrees. But he was getting somewhere between 14, 15, 13 degrees. So when I investigate around, in this occasion, the first thing you should do is take a torch with you, go inside the cold room, close the door behind you, and see if there is any gaps there on this one, on the door or any panels, any visible gaps, so the air can entering inside the cold room. So when I see there was a big gap in the door, and so I said, look, the problem is not your equipment is all working nicely. The problem, you got a big gap in the door. So all I have to put a new lock to keep the keep the door stick with the panels. And once we get rid of that gap, and you will get your couple of degrees cooling. So the next day when I come, the temperature was 18 degrees. So, well, I ran out of the time, and maximum 15 minutes I can do. I will continue with this troubleshooting, I hope it helps some um, beginners for the job. The idea is to always be confident. If you can't do it today, figure out, talk with the other engineer, and go and do it another day. The job. See you guys. Bye.